Good day, everyone. So, for our Laboratory 1.2, we are here to discuss object-oriented DBMS. So, for the contents, first one is we have the definition of object-oriented DBMS. Second one would be building blocks of an object-oriented database. Third one would be the key characteristics of object-oriented database. The fourth one is the features of oriented DBMS. Fifth one would be the examples of object-oriented DBMS. The sixth one is the advantages of object-oriented DBMS. Seventh is the disadvantages of object-oriented DBMS. Lastly is the conclusion.
Definition of object-oriented DBMS. Object-oriented databases are a type of database management system. An object-oriented database, or also called as OOD, is a database system that can work with complex data objects that mirror those used in object-oriented programming languages.
For the building blocks, objects. Objects are real-world entities such as a specific task in a to-do list. Take the garbage out. Attributes and methods. An object has state and behaviors. Objects also have properties, attributes like name, status, and create date. For classes, are a grouping of all objects with the same properties and behaviors. For pointers, pointers help access elements of an object database and establish relations between objects and addresses that facilitate both object access and establishing relationships between objects.
So for the key characteristics of object-oriented DBMS, we have polymorphism, inheritance, encapsulation, and abstraction. So you can see this for as similar to object-oriented programming because object-oriented database management system is closely related to object-oriented programming concepts. These four attributes describe the critical characteristics of object-oriented management systems. For the features of object-oriented DBMS, we have object-oriented data model, complex data types, automatic schema management, high performance, data integrity, concurrency control, scalability, and support for transactions.
Examples, we have a features and the description. For features, query language descriptions is language to find objects and retrieve data from the database. Transparent persistence, ability to use an object-oriented programming language for data manipulation. For ACID transactions, transactions guarantee all transactions are complete without conflicting changes. For database code caching, creates a partial replica of the database, allows access to a database from program memory instead of a disk. And last is for recovery. Disaster recovery in case of application or system failure.
Sa advantage naman po ng object-oriented DBMS, complex data and a wider variety of data types compared to MySQL data types, easy to save and retrieve data quickly, seamless integration with object-oriented programming languages, easier to model the advanced real-world problems, and lastly is extensible with custom data types.
And for disadvantages, first, not as widely adopted as relational databases. No universal data model, lacks theor- theoretical foundations and standards, does not support views, high complexity causes performance issues, and last, adequate security mechanism and access rights to object do not exist.
Last, for conclusion, object databases provide a modern approach to database modeling, mirroring the use in object-oriented programming. These characteristics make object databases suitable for projects with complex data which require an object-oriented approach to programming. An object-oriented management system provides supported functionality catered to object-oriented programming where complex objects are central. This approach unifies attributes and behaviors of data into one entity.
For the object table class, it is designed to manage a table-like structure for storing objects in a code. So it utilizes a list, which is the self objects, for object storage and includes the following methods. So the first method is init. This method initializes an empty list for self objects when a new object table instance is created. Next is the add method. It is responsible for adding objects to the table. It takes an object as input and appends it to the list of objects. The third one, and lastly, is get by ID. This method allows you to retrieve objects from the table based on their unique ID. It accepts an ID as an argument and searches through the list of objects to locate the object with a matching ID. If found, it returns the object, otherwise, it returns none.
Next is yung my object class. So yung my object class is represents the objects you want to store in the table. Each object has three attributes: the ID, name, and age.
For the third one, we create an object table instance. So we create an object we create an instance of object table called table. This instance will be used to store and retrieve objects.
Next is creating and adding objects. So we create two my object instances, which is yung obj1 or my object and obj2. It representing two objects with different attributes, which is ID, name, and age. And we add these objects to the table using the add method. As a result, obj1 or object 1 and object 2 are appended to the dot objects list inside the table.
For retrieving and printing objects by ID, we use the get by ID method to retrieve objects from the table by their unique IDs. We attempt to retrieve object 1 and object 2 by their respective IDs using the get by ID method. So, for example po, the ID for object 1 is 1 and the ID for object 2 is 2. If an object is found, we print its name and age attributes. If an object is not found, we print a message indicating that the object was not found.
And for the output of this DBMS OP, the code outputs the names and ages of the retrieved objects if they exist in the table, or it prints a message stating that the object was not found if it's not present. This code provides a simplified example of how you can create a basic object-oriented database like structure to store and retrieve objects using a simple table-like representation. Keep in mind that this is a minimalistic example and doesn't include many features typically found in full-fledged database system, such as indexing, querying, or persistent to this.
That's all. Thank you po.